In this lecture, we're going to discuss the importance of our water resources. Water is considered to be our most precious resource on the planet. We often take it for granted, though, because of a functioning water cycle. And so in this lecture, we're going to take a look at the nature and value of water. We'll take a look at how we use it, and then issues with how to plan for its use. To begin, let's talk about water as a resource on this planet. And we often think of it as renewable, which it is because of a functioning water cycle. But because of climate change and increasing human population and demands on water, we are finding that it's not as renewable and sustainable as it once was. And we're starting to realize that water, even though 99% of the biosphere and 71% of Earth's surface is covered with water, the usable water that we require for our society is quite limited. Perhaps this visual will help you to understand that Earth's water budget is something to take serious. There's plenty of water on planet Earth, as we can see here on this graphic. 96.5% of the water on the planet, though, is in the oceans and considered to be salt water. And only 2.5% of the water on the planet is freshwater. Now, as a terrestrial-based organism, as humans are, we depend on freshwaters for survival. Now, let's break that freshwater component down a bit. So when we look currently, about 2/3 of all of the available freshwater on the planet is frozen in glaciers. Now that becomes an issue with climate change as glaciers are melting and seeping, or melting and flowing into the ocean, I should say. The problem there is that this large chunk of Earth's fresh water is going to become salt water if we do not help to mitigate that. Almost 1/3 of that fresh water is in the ground, and only about 1% of the available fresh water flows over land surface. So only about 2.5% Earth's water is freshwater, and then only about 1% of that is what we see in lakes and ponds and rivers. So that's pretty significant. But on this particular chunk of the graphic, 1/3 is available for human use. Now let's break down that surface water. So this is where we see a good chunk of it is involved in lakes, such as the Great Lakes and Lake Okeechobee in Florida, if we think about that. But we forget too, there's a lot of water in the atmosphere as well. Now what's interesting is some of that water is frozen as permafrost. It's a permanent layer of the subsoil in the tundra. So there is a good amount still frozen in the ground. But this graphic here is important in the sense that, not that you're going to have to memorize these percentages or anything. So this may not necessarily be a graphic you need to include in your notes. Maybe something simple to help you visualize that water, even though it is renewable, it is in a sense finite because of a growing human population and the stress that we put on that. So what we see is the potable water that we require is limited. So potable water is basically water that's available for drinking. It's unpolluted and available, right? So as a result, we can see that there's a great deal of water stress on our planet. No surprising, we can see areas that are adjacent to deserts right along the 30-degree latitude mark right here. We can see our deserts, areas where there's not a whole lot of rain along the 30-degree latitude line. No surprise that there's water stress there, but we're starting to see it creep into other areas where we may not expect it. And so here's some statistics to consider. About 2 billion people, or 1/4 of the world's population, live without access to safe drinking water. That's a lot of people, right? And water, like, you can live a month without food, but you can only live 3 days without water. So that's a very, very significant thing for a good chunk of Earth's population. About 4 billion people, roughly half of the population, have water scarcity at least some point in their year because of a dry season. It is estimated that by the year 2030, half the global population will experience severe water stress. As the climate continues to change, we affect the functions of the water cycle. Areas are getting less rain than they had in the past and having more severe droughts, and we have a larger population of humans that require it. So we're starting to see even in a lot of conflict over water and its use. We're even seeing water wars in certain areas, especially in less developed countries. But even in developed countries like the United States, different states will sue each other in federal court over access to water. And we'll talk about that a little bit later on in this lecture, give you some examples of that. Now, probably in recent memory, one of the most significant examples of water stress for a developed country was in South Africa, specifically the city of Cape Town. There was a severe drought, as you can tell from this graphic, that basically lasted from 2014 to 2017. They still had their rainy season, but it was not as rainy as it had been in the past. And their water resources were depleting significantly. And they were like within just a few days, I believe it was, of what they call day zero, which was the name of the point at which they would have to turn off water flowing to homes. So that they would turn off the municipal taps. Now that was a concern, right? I mean, you can imagine we take that for granted. We turn on the faucet at home, you have water. Fortunately, in 2018, they had significant rains that returned, which again is kind of part of the model of climate change. It's not that we're not going to have rain, it's just sometimes it may be unreliable and may fluctuate as the climate is destabilized because of changing temperatures. And we'll talk more about climate change later on in a lecture and the mechanisms behind it. But water isn't as reliable as it used to be. Now, you may think, well, that's just an African problem. Well, it's interesting that in 2014, roughly around the time that the Cape Town water crisis was beginning, Atlanta, Georgia was within 35 days of day zero. So this can happen even in the United States, and this was prompted by severe drought at the time. So now that we understand water should be treated as a limited resource and not wasted, how do we use it? Where can we find areas of waste that we can improve this and conserve water? Because it is a very important resource. Well, let's take a look at this pie chart. That largest chunk of the pie is for agriculture. We use 70% of all the water that we use on this planet is used to grow food, livestock, any farming activities, and that's primarily through irrigation. 20% is used for industry. This is used for the manufacturing processes, and we'll take a look at the details of that in just a moment. And then 10% is domestic use. That's what is in home and public services, right? So that's the water we commonly think of that we interact with on a daily basis. Well, let's break these down into their components and talk a little bit more about specifically what's going on. We'll talk about irrigation water first, or agriculture. Most of the water for irrigation is going to be used to irrigate crops. And here are three primary methods of how we irrigate. And they all are going to have different components of sustainability and ease. Surface irrigation is easy. You just flood the field, right? Sometimes is known as flood irrigation or gravity irrigation. This can be pretty wasteful because a lot of that water that sits on the surface will evaporate. And this can also lead to water logging. We'll talk about that concern later. But it uses a lot of water and can be quite wasteful. But it doesn't require much energy or input, right? You just have to dig channels and release some water on it. But this tends to be quite unsustainable and useful. Now, sprinkler irrigation is what we think of. That's probably what you have on your lawn, where you spray the water on there, which mimics rain. It's better than flood irrigation, but it's still quite wasteful, especially in areas like Florida where we have high temperatures, where a good portion of that water evaporates into the air before it even gets to its intended source, which is on your grass or on your crops. So that's why in Florida they encourage us to irrigate or spray our lawns in the evening when evaporation is going to be minimal. Now, the most sustainable and water conserving process is what we call micro irrigation. Sometimes it's referred to trickle, or even I've seen on the College Board they refer to this as drip irrigation. Basically, this is where you have a system of tubes that deliver water at the roots of the plant. So the plant is getting plenty of water, but we're not giving it too much water. This significantly reduces water loss, as we can see here. And you can actually get this for your garden if you go into any home improvement store like Home Depot or Lowe's. You can actually get a drip irrigation system that will help to conserve water for your home. We also use water in agriculture to give to our livestock, right? They need an access to water to drink and also maintain their health. And also when we process the crops, after we harvest them, there are some important uses in processing and milling. We also use it in pest control, fertilizer application, a good number of reasons that we use water. So no surprise then that 70% of the freshwater resources are intended or used for agriculture. So if we're looking for the biggest impact on conserving our water resources, conserving it in agriculture is probably number one. Focusing on sustainable irrigation processes and conserving how much pest and fertilizer application that we use. Now, industrial water use is about 20% of our global usage, and most of that water is used for cooling the machinery and the whole process of industry, right? Because that helps to prevent wear and tear on the mechanics. We also will produce a lot of steam for energy production. That's kind of a basic fundamental component of generating electricity. Is you need a heat source to boil water to generate steam. The steam is used to spin a turbine and generate electricity. We'll talk more about that in a later unit. The manufacturing process also will require water to dissolve chemicals. In paper production, use a lot of water to take the wood pulp and turn that into paper. And it's also used in fabricating many products as well. Now, we have a fourth use of water, but it doesn't consume it. So sometimes we call this non-consumptive. This is in-stream water use. This is basically we're using the water, but we're not actually taking it out of the reservoir. So for example, hydroelectric power is using water flowing down a river through a dam, as you see pictured here, and that can generate electricity. Recreation, we use water for boating, for swimming, for fishing, right? So this is kind of a cultural service of water. And then also we use it for navigation. So we'll even have cargo ships, which will go through rivers and such to deliver goods to areas that are in and around the Great Lakes in Canada and the United States. Now, 10% of the water is domestic, and this is probably the one that we'll focus on the most in terms of how you as an individual citizen can make an impact on what we call your water footprint. So domestic water is used in homes, right? And when we look at this pie chart, the largest chunk of the pie in your home, typically, you use most of the water in your toilets. So the flushing of the toilet requires a lot of water, and so that is somewhat of an area of concern. We'll come back and touch on that in just a bit. The second largest is washing clothes. So laundry uses a lot of water. Showering, running faucets, either in the kitchen or bathroom. And surprisingly, 14% of water use in the United States is from leaks that are not observed. This could be a leaky toilet, it could be a leaky garden hose. So it's one of those situations where it's worth probably evaluating your home to see if there are any leaks, because you might be wasting a significant amount of money on it. And then, of course, other things including baths and dishwashing and any other intended use in water, right, in the house. So, but again, the big ones are toilets, washing clothes, showering, and using faucets. Interesting graphic here to kind of show you the relationship, or at least the economics of water use. The yellow bars that are on this graph here show you the price of water. And you'll see in the United States and Canada, water is pretty cheap, whereas in Europe, it's expensive. And this is all about supply and demand. So the supply, demand is high in both regions, but the supply in Europe is a little bit less, just simply because of surface area. Well, no surprise then that in Europe, because the price is high, the use is low. Whereas in the United States and Canada, water use is very high because it's relatively cheap. Now, this is why if you've ever gone to Europe, they don't they don't just bring a glass of water to your table. It's not considered a free resource because it is more expensive there, and so businesses have to account for that. And in homes, we see interesting behavior. Showers over in Europe are not as long because a 5-minute shower would be very, very noticeable on your on your bill, on your water bill, because it's quite expensive. Let's talk a little bit about that, and we're going to return to our friends in Cape Town that again experienced severe water stress. They were within just days of the city taps being turned off. So they had to learn about the practices of water conservation real quick because they were actually put on a quota or a daily limit of 13 gallons. So they had to figure out, all right, well, how are we going to conserve this water and not waste it, right? So when we look in the home, you can see that a toilet can flush up to 6 gallons, right, every time. That's an old toilet. New toilets, of course, are much more efficient. But still, if you only have 13 gallons a day, you need to figure out how to conserve that water. And the behavioral change there that leads to the conservation of water that, again, Cape Towners had to learn was don't always flush things. Like definitely don't flush tissues, use the trash can. Or they kind of had this saying, if it's yellow, let it mellow, right? So you don't always have to flush urine. As it doesn't have the same sanitary concerns as feces does. So they would often just let it mellow before they would flush. Shorter showers, right? The technology that affects that is to install low flow shower heads that conserve water. They're not using as much water as an old shower head. But the behavioral change was to take shorter showers or even what we call Navy showers. This is something that the Navy learned to conserve water on boats and submarines that basically turn the water on, turn it off, lather up, and then turn it on real quick. And so that conserves an awful lot of water. They do this in areas of the Caribbean as well because there's just not as much water down there as well, being in the middle of the ocean and such. So faucets, updating faucets are important. Of course, probably the most simple behavior that all of us can undertake is just turn the faucet off when you're brushing your teeth or washing your face or even shaving. That conserves water significantly. Washing laundry, we know that was a big one, big part of our water consumption. So having a more efficient washing machine that can adjust the amount of water based on how much laundry you put in there. So these are very efficient. So if you have a small load of laundry, the newer machines will sense that and just not use as much water. Also, just don't wash clothing unless it really demands it, right? Jeans can probably be worn several times before they need to be washed. A trick that Cape Towners learned and other people that have areas of expensive water have learned is if you put your jeans in the freezer overnight, it actually freshens them up quite a bit and cleans them almost effectively as washing them. It doesn't remove stains, but it keeps them from having a smell. And then dishwashing, dishwashers, same thing. So more efficient dishwashers use less energy per load, but the behavioral change is to make sure that you're filling your dishwasher before you run it. Just don't put a few pots and pans in there and then run it because that's, per intended use, you're using more water. So we're not at this point yet in the United States, but as you can tell, a developed area like Cape Town, they were there pretty quick. And so it may, in the future, be a point where we have to adopt some of these behavioral changes. Right now, we don't. And so you can continue to take your long showers, but don't be surprised if down the road that water prices go up because of a concern of conservation. And therefore, that 5-10 minute shower you're used to taking might become quite expensive. And so, if you're living on your own and budgeting for yourself, you might want to take shorter showers, or your parents may start yelling at you to take shorter showers. So, on the horizon, we may have to adopt some of these behavioral changes. Now, another important thing to consider when conserving water is our virtual water use. And so, virtual water conservation is basically adapting our eating and shopping habits to conserve water. Eating will help to conserve agricultural water, and our shopping will help to conserve the industrial water. So let's look at some examples. In the graphic that we're going to see here is taking a look at the gallons of water needed to produce a pound of food. So if you want to, every pound of potatoes that are grown, we use about 31 gallons of water. And that's from irrigation to grow the potato plants. For a pound of apples, 84 gallons. Why is that more? Well, consider that apples grow on trees, and trees require more water than a ground shrub like potatoes. Corn is one of the more water thirsty crops on the planet, and so that even requires more water than trees do. And yet, corn is one of the easiest and fastest and most commonly grown crops in the United States. So that means we're using a lot of water to grow corn, whether it's for our human consumption or for animal feed or even biofuel, as we'll talk about in a later unit. Bread, even though it's a plant coming from wheat and rye and other things, there's a lot of processing involved in that as well. So they're pretty, all that component is, going into bread requires a lot of water as well. Now, when we get into our meat, chicken is 469 gallons of water for every pound of chicken. Now, why is that? The reason is that now we're going up the food chain, right? So the chicken requires a lot of grain, so therefore that is going to be a lot of irrigation to grow that grain for chickens. Now, keep in mind, what percent of the energy and biomass goes from producers up to chickens? Well, it's only going to be 10%. 90% is lost. That goes in hand with water as well, right? If you have to use if only 10% of the grain you grow actually is going into producing chicken biomass, then that means only about 10% of the water is also being used. That's a lot of water that is growing the food for chicken is basically the point there. For pork, it's much higher. The highest of them all is beef, because cows graze a lot of grass, and so they have to eat a lot. They have a large biomass, and so they require a lot of water for their pasture land. Now, what about the virtual water footprint for products we buy? Well, a cotton t-shirt, a pound of cotton is going to be 766 gallons. That's simply from growing the cotton plants. Very, very water demanding. Paper, because of growing the trees and the paper pulp. So one ream of paper is over 1,200 gallons of water. So another reason why to recycle paper. That's important. Blue jeans, that's the one that demands the most. Why do blue jeans? Well, denim is cotton based, so it requires a lot of water to grow cotton. And also, there's a lot of water used in the dyeing and manufacturing of the jeans. So how do you help reduce water stress and your water footprint? Well, make sure that you're not buying fashion, like fast fashion, as much as you used to. Like, you don't need to buy a pair of jeans every week or something like that. And also, this is where going thrifting would be beneficial. They're cheaper, and plus you're buying, it's kind of like recycling your clothes in a sense. And so it's not going to require any water to produce jeans that are in a thrift shop. Let's look at some issues that go along with water planning. So one concern that we see that is becoming very common is salinization of water. This results from irrigation. When we irrigate the land, what's happening is we tend to use groundwater. So it's not purely distilled water like rain. That means the water that we're putting on our crops has some minerals and salts from the ground. It's still fresh water, but there are some dissolved salts. When the area is dry, and I apologize, this resolution on this picture isn't all that great, but um, if the area is dry, which it usually is, if we are irrigating our crops with groundwater, then that probably means we're not getting as much rain. And so therefore, there's going to be a lot of evaporation. Well, when water evaporates, it leaves the salts and minerals behind, and so you have the buildup of salt in the soil, and that can reduce your crop output. So this causes two stresses. One is it's using water, so water stress, and then crop stress as well, because we're not able to grow as much food as we used to, and this could lead to trying to irrigate, or excuse me, to irrigate more and even use fertilizers to ramp up crop production. Now, the opposite side of that is water logging, using too much water and waterlogging the soil, which can even raise the water table in this case. And you can see this field is flooded. This could be an area that just has received too much rain. Because again, climate change is about instability. It could be that we have prolonged droughts like in Cape Town, or there could be areas that get too much rain. And you can see the corn that is grown here is stymied by too much water. Remember that important soil component is to have about 25% air. Well, there's no air in the soil here for these crops growing there. And so excessive watering can come from poor irrigation practices or even natural events like excessive rain. And we can see that waterlogging can really reduce crop outputs, even in barley and wheat as we see here. Another issue with access to water is mining water out of the ground. Areas where um, there's not as much rain, a lot of individuals have turned to drawing water up from aquifers or groundwater. And probably the most profound example of excessive use of this resource is seen in what we call the Ogallala aquifer, or the High Plains aquifer in the Midwest of the United States. This is an area that grows a lot of corn and a lot of crops, but they have not been getting a whole lot of rain. And so they've relied heavily on water from this aquifer. And you can see there are areas, especially in New Mexico and Texas, where the water table or the level of the aquifer has depleted about 185 feet. So that means there are areas where the recharge or the rainwater that percolates to this aquifer is lower than the demand. So this is called overdraft. We're taking too much water out of the aquifer and not allowing nature to refill it. Related to that is overdraft of water along coastal areas or where areas have salt water. So under normal circumstances, water will flow through underground aquifers towards the ocean, and you have a little mixture of the salt and fresh water at the estuary outlet, or basically the area where the salt water meets the fresh water. That's typically normal, right? And you can drill a well here and get fresh water along the coast. What we are seeing, though, is unsustainable drafting of water. More wells, more homes, more agriculture has actually created a backflow of salt water into this freshwater aquifer, as we see here. And now this water is completely unusable. You can't irrigate your crops, you can't run it to homes. So this is known as saltwater intrusion. And major coastal areas along California, also in Miami, are threatened with this problem. Water diversion is where we move water to areas we want it to go. And this is where we can run into problems with water conflict. Some areas we want water for irrigation, some for industrial use, others for just construction. And so the Colorado River is diverted quite a bit and has become a point of contention for states and cities in the southwest of the United States. So we look at some of these projects. Probably the most famous is the Hoover Dam, which of course is built to help sustain Las Vegas. So obviously Las Vegas, being a big metropolitan area in a city, requires water significantly, but it's also annoying for probably citizens downstream of Las Vegas, Nevada, to look up and see them having ornamental displays of water fountains and such, when they are sometimes not getting access. Sometimes this Colorado River doesn't even make it to the Gulf of California because it dries up. Well, there's other dams along here, and this is a dam along, I believe this is the Gila River, part of the Colorado tributary system. And this dam, of course, is going to support Phoenix, but also this supports agriculture in Southern California. So this, we can see three entities here, three states. We've got Nevada, Arizona, and California, all basically trying to tap into the same common resource and depleting it. Classic example of tragedy of the commons here, and we can see that there's been some arguing and even legal battles over access to this water. Now, something that relates to water planning issues is the protection of wetlands. And wetland preservation is protecting areas where we have marshes and such, but also restoring them. We've learned that this is super, super important. And it's now really, I believe it's federal law still, that if you are developing land and turning a wetland into like a development or shopping center, you need to recreate or mitigate another wetland area because we've learned it's so valuable. Well, why are we losing wetlands, areas like marshes and stuff? Why are we losing them? Well, here's most of it's urban development, and we can see in this graphic here in Florida, a lot of the development along the east coast, southeast coast of Florida has ruined and taken a lot of wetlands because basically we have a lot of the city limits are pushing westward into the Everglades. We see a lot of agriculture and forestry are impinging on wetlands too. So the big chunk of the pie we see here represented in Florida, urban development, and then also our cropland, growing vegetables and also dairy farms. So why is this a concern? Well, if we look at wetlands, they're a very, very important component of our water cycle and our water resources because their ecosystem services are important. Wetlands filter water for us, and so they get a lot of the nasty pollutants and concerns for us. So they help to provide clean water, they prevent erosion, and they also regulate flooding from storms. They also absorb waves from hurricanes, and they also increase biodiversity of waterfowl, basically birds. They provide food for many aquatic species and nursery sites for fisheries. So protecting wetlands is an integral part of making sure that we have plenty of access to clean, usable water. They're an important part of the water cycle. And so that's why wetland preservation is critical to planning how we use water in the future. All right, little AP practice to finish up here. So here's your multiple choice question. Which of the following methods of agricultural irrigation results in the loss of the least amount of water by evaporation? Well, the correct answer is drip irrigation, right? This is the irrigation that just puts water to the roots of the plant, so there's no evaporation. It's pretty much all underground. Here's your FRQ, so you can go ahead and pause this and give it a shot, and then I'll show you the grading key, and you can grade it yourself in just a bit. Okay, so we have three components here. This is talking about the Colorado River, which we talked about, right? The Colorado River runs about 1,400 miles from the headwaters of the Rocky Mountains to the Gulf of California. The river has many dams, aqueducts, canals that divert water in order to supply water for electricity, irrigation, recreation, and domestic use. Part A, describe and discuss two environmental problems that are associated with water diversion. Then for Part B, if there is a shortage of water, choices will have to be made as to whether water should be diverted to urban areas, agricultural areas, farms, or ecosystems. Make an argument for diverting water to urban and an argument for permitting flow to natural areas. So I'll show you the answer to that in a second. And then thirdly, identify another example other than the Colorado River, a large-scale water diversion. All right, so here is the first one for part A. This is taking a look at the describing and discussing, right? So you have to describe and discuss some concerns. So the first one here is a water diversion. Basically, building a dam prevents nutrient-rich sediment to flow downstream. This decreases plant growth downstream, right? Because there's less fertile soil in floodplains. You can pause this and take a look at the other examples here too. Now for part B, the argument here are some arguments for urban consumption, right? So why do urban waters need water? Well, they need it for domestic uses and also industrial uses. Why do natural areas need it? Well, they need it for plant functionings, for biodiversity, for wetland filtering, right? So all of that. And then for C, another example, well, these are all some interesting examples. There's plenty. So you could kind of go with a local example here, right? We could talk about the Kissimmee River situation. You could talk about St. Johns River as an interesting one. Miami would like to tap into the St. Johns River, and so there's conflict between Jacksonville and Miami. We have the Everglades situation in Florida as well. So those are all some examples, and the one that they use an example here is James Bay. This is something you probably aren't familiar with, but this is an example of how you would build your answer. Talk about, well, here is this hydroelectric power plant was built in the 70s, and this led to a number of caribou being drowned and mercury poisoning in people. So there are a lot of issues related to that. So there were a number of issues that you could have picked to discuss this. And sometimes they put these questions in here because they want to see your understanding of common current events and historical events on environmental problems.